Hi grade 10s and welcome to this video. In this video, we will be working on the Mathematics Paper 1 for June 2025, and this is specifically from the Gauteng province. Question 1 says, consider the expression and we are given k equals 3n over the square root of n plus 5. And we need to write down the value or values of n for which, and the first question is for which k is equal to 0. Okay, so they said k is equal to 0. You see k? Just make it equal to 0. So we'll say 0 equals 3n all over and then the square root of n plus 5. And they want us to solve for this equation. Okay, so in this equation, you see that to solve for n, it's a lot like, with quadratic equations, right? Where you have something times something is equal to 0. Let's say n plus 1 times n minus 3 is equal to 0. The only way we can actually get 0 is if this was equal to 0, then you said 0 times whatever this number is, and then it would give you 0. Or if this was equal to 0, and then you said that number times 0, and then you get 0. In the same way, we are dividing here, but there's something we need to take note of. If the numerator is equal to 0, then we can definitely say that's 0 and then we divide by whatever this is, and then it would really give us 0 because we know that 0 divided by any number except for a particular number would give you 0. Of course, if that number is real. So the number that we need to now take note of is if this whole denominator ends up becoming 0. If that becomes 0, you can't actually solve for n. Then we have a case where this is undefined and we can't actually find the value of this. Okay, so we need to ensure that this denominator never becomes equal to 0. So I see that it says square root of, but if you take n plus 5, just ensure that it's not equal to 0. So we're going to ensure that that's not the case that we are working with, meaning it can be anything else but this. So I'm just going to still find out this just in case, your answer ends up leading to this, and then you shouldn't take that. So we will say that n should not be equal to, if you transpose, that is negative 5. So if your answer happens to be equal to negative 5, it's not a valid solution and we can't take that. Okay, so with that, we know now that the only way that this equation can actually be true, we say this divided by that and we get 0, is if this numerator is equal to 0. Because if you say 0 divided by any real number, you're going to get 0. Okay, so that would mean that 3n should simply be equal to 0. And then we can divide both hand sides by 3. And n should simply be equal to 0. And that is our answer. N should be equal to 0 if we are saying that k is equal to 0. That would be the value of n for which k would be equal to 0. Moving on to the next question. Question 1.2 says k is undefined. Okay, so we need to tell them the value or values of n for which k will be undefined. And we just spoke about this. You see, if this fraction has a denominator equal to 0, then it's going to be undefined. So if that denominator, you can say the square root of n plus 5 is equal to 0, or just focus on the n plus 5, it's still fine. So I'll just say n plus 5 is equal to 0. This is when it will be undefined, and then solve for n. So therefore, this is when n is equal to, transpose, negative 5. And that's when it will be undefined. Okay, so that is where k is undefined. Okay, moving on to the next question. And then question 1.3, we need to solve for n, for which k is a non-real number. So what should n be for k to be non-real? The way that we get a non-real number, because we have a square root here, is if you square root a negative number. Okay, so we get a non-real number if that under the denominator, under the radical really, okay, because we have a square root there. If n plus 5 is a negative number, and negative numbers are numbers that are less than 0. Okay, on a number line, 0, numbers less than 0 are negative. So we'll just solve for this inequality. And it's linear, so all you have to do is transpose 5. So n is finally less than, that becomes negative 5, and that would be our answer. If n is less than negative 5, your answer is going to be non-real because it's always going to give you negative numbers under that square root. And that is our answer, and that is it for question 1. Question 2.1 says, simplify the following expressions fully. Okay, so here you can see that we have one term multiplying by two terms. So we can distribute by foiling in. And so 4p multiplied by 2 is 8p. And then 4p multiplied by negative 5x is negative 20px. And that is our answer. Moving on to the next question. Okay, here again, we're just going to expand and simplify. But just note that we are multiplying something with one term, with something with two terms, and then something with two terms. With this case, it is best to multiply the binomials first. Okay, so the two terms, the two terms. So we'll leave the negative 2 outside and then distribute. So we're multiplying 2x times 3x, and that gives us 6x squared. And then we have negative 4x and positive 9x and negative 6. And then we can distribute here. Okay, but just simplify this just to make it simple for yourself. And this is negative 2, we have 6x squared. And if you say positive 9 minus 4, we get positive 5x and minus 6. And finally, distribute the negative 2 in. So it multiplies to become negative 12x squared, and then negative 10x, and finally positive 12, and that is our answer. Moving on to the next question. Next question, we're simplifying, okay, but this time we have 4x plus 1 all squared. If you have x squared, this can be expanded to x times x. Okay, so 4x plus 1 is 4x plus 1 times 4x plus 1, and we'll distribute that. Now, you can choose to distribute this as and start multiplying it out, or you could do this. So the quick method is you take this and you square the first term. So 4x all squared is 16x squared, and then take the last term and you square that, so it still gives you positive 1. Then say first term times second term, and that gives you 4x, and then you multiply this by 2, which gives us a positive 8x, and that's what we have that side. And then moving on to the second term, you see that here we are multiplying two values, but they are clearly the result of factorizing difference of two squares. Do you see that this is 3x, this is 3x, that's a 1, that's a 1, and then we have a plus and minus. When distributing, you can choose to FOIL it out, but look at what's going to happen. So we still have the minus there, and then what they become is you're simply just going to multiply the 3x with the 3x to become 9x squared, and then the 1 with the negative 1 to become minus 1. And that's all it would simplify to if we have the case of difference of two squares. Okay, let's distribute. So we have 16x squared plus 8x plus 1, and distribute. That's negative 9x squared and positive 1. Finally, add your like terms together. 16x squared and then minus 9x squared, we get 7x squared, and then we still have positive 8x, and then 1 plus 1 is 2, and that is our answer. Moving on to the next question. The last question for question 2 says, factorize the following expression completely. Okay, so we have this expression, and let's just examine it before factorizing. Okay, we have how many terms here? Remember that terms are separated by plus or minus signs, but brackets join terms together. So though there's a minus sign here, this is multiplied to this. So this is one term now, and that is another term. Now, in these two terms, do you notice something? The bracket looks very similar. This one says x minus 1, and that one says 1 minus x. Here, the x is positive, but here the x is negative. While here, the 1 is negative, and here, the 1 is positive. This is a clear case when there is a common factor of negative 1 in one of the brackets. You can take that out. And this is how we do this. We are going to rewrite the first term and leave it as it is. So it's x squared, and then we have x minus 1. And we're going to take out a negative 1 from this bracket. So from both terms in the bracket. And that negative 1 will go in front of the 25. Really, we take out that negative and it multiplies to the positive 25 to become negative 25. And then open our bracket. That negative 1 was taken out, okay? So what would be left in this negative x if you take the negative out? Because it's a negative, you must have said negative multiplied by positive to get negative. So if you take out the negative, all you'll be left with is a positive x. Likewise with the 1. It's a positive 1. So you could have gotten positive 1 by saying negative times negative, okay? Or you could really just see this as dividing or multiplying each of these terms by negative 1, okay? That's a simpler way to work with that. So negative x times negative 1 is positive x. Negative 1 times 1 is negative 1. And there we go. Our brackets now look the same. Okay, we still have two terms, clearly separated by this minus sign. But in each term, we have an x minus 1. And so we're going to take that out as a common factor, or you could call it a common bracket. So we can take out x minus 1. And then what are we left with in the first term? When x minus 1 comes out, if we divide just to see what is left, we can see that x squared is left. Okay, you just look at this and you say, what do you multiply to this to get back to this? Okay, and that will be the x squared. So that's why it's easier to just divide. And so we have x squared, and then do the same thing here. The second term divided by that common factor, they would cancel and you're left with negative 25. Okay, so we're trying to factorize here. We have clearly factorized by taking out a common factor as a bracket really, okay, x minus 1. But now looking at this, has this been factorized fully? No, okay, because we can still factorize over here. Notice how this is x squared and that's 25. These are both square values, okay? So 25 square root of 25 is 5, square root of x squared is x. And we have a minus, so we have difference of two squares going on here. And so we can factorize that. So this is x minus 1 still, and this now becomes square root of x is x, square root of 25 is 5. So we have x and 5, and we just write plus and minus, and there we go. So that is our answer, and that is it for question 2. Question 3.1 says, solve for x if 3.1.1, x minus 3 equals 18 over x. Okay, so in this equation, we just need to isolate x, okay, or get x alone, but we have an x over here. So we can get the x's together simply by making this a fraction as well. So since it's a fraction and a fraction, we can cross multiply. Okay, you could have also seen this as getting rid of the x in the denominator by multiplying both hand sides by x. With that being said, also just note that if x is equal to 0, then this is going to be undefined, okay? We won't be able to solve x. So just note that x should not be equal to 0. Okay, so cross multiply, and we're saying x times x minus 3. This is one term times two terms, so the x needs to multiply to the x and the negative 3. So that would give us x squared and negative 3x, and then it's equal to 18. And now you can transpose the 18 because you multiply 1 and 18, of course. And so this is x squared minus 3x minus 18 equals 0, and we can solve for x. So open up two brackets, equate to 0. X multiplied by x gives you x squared, and then factors of negative 18 that can give us a 3. We can try 6 and 3. And if you make the 6 negative and you make the 3 positive, we know that negative 6 times positive 3 is negative 18. But negative 6 plus 3 is negative 3. So there we go. We do get that middle coefficient. So we know that our factors are negative 6 and positive 3. And so we have something times another thing gives us 0. The only way this is possible is if x minus 6 is equal to 0 or x plus 3 is equal to 0. And so finally x is equal to 6 or x is equal to negative 3. And these are our answers. Moving on to the next question. The next question, we have been given an inequality. So we need to solve for x in this inequality. So 2 minus x is greater than or equal to negative 3 but less than 0, where x is an element of real numbers, and we also need to represent our answer on a number line. Okay, so solve for this inequality. We need to isolate x. So leave x alone here. Remember that this inequality is really two inequalities that had related x values, and so they were put together. If you wanted to separate them, we could have written this as 2 minus x is greater than or equal to negative 3, or 2 minus x is less than 0. Okay, so that would be them separated. It's just this together and that together. But we can just solve for x like this. So we can get x alone, or negative x really, by transposing the 2. Okay, so we're going to have negative 3, and it's a positive 2, so it becomes minus 2. And then we have 0, and minus 2. Okay, so negative x is greater than or equal to, and that becomes negative 5, but less than negative 2. So this is what we have so long. Now, the x is negative. We need to make it positive so we can actually solve for x and not negative x. So to do this, you can divide all sides by negative 1 or multiply all sides by negative 1. But the thing with inequalities is if you multiply or divide by negative 1, it causes the inequality to change. And it's nothing complicated. It's simply just, for example, if you said negative x is less than negative 1, okay, I could decide to just take this x over, make it positive, and take the 1 over, make it positive, and then just rewrite the inequality exactly as it is. And in this way, I wouldn't be dividing, but my inequality right now looks awkward because it says 1 is less than x. So at this point, I could just write the x on the left-hand side and the 1 on the right-hand side, but I would still have to follow what the inequality says. The inequality, the mouth, okay, the open part, is facing the x. So draw it facing the x. And there, it's telling you that x is greater than 1, which is the same thing as 1 is less than x. Okay, so it's just the way it has been written. So even if we took things over, it would still work. But of course, in this case, not a good idea to do that because these are two separate inequalities and we're just trying to solve for x. So you don't want to break them apart and start solving. Okay, so change your signs, invert your signs. And finally, we know this is going to be positive 5 and that's going to be a positive 2. And now our x is positive. And now write it correctly. So we are saying that x is simply, and we're going to put the smaller value here, which is the 2, the larger value here, the 5, and we're still going to follow what the inequality says. And so now we're still going to draw these signs correctly, okay, based on whatever they're facing. So let's start with the smaller one, the 2. Do you see that when you look at the x versus the 2, the inequality, the mouth, the open part, is facing the x. So draw it like that, facing the x. And then with the 5, the mouth is facing the 5. So draw it like that, okay, facing the 5. And so this just means that x is greater than 2, but less than or equal to 5. And that is our answer. And that is it for that question. They also said represented on a number line. So let's do that. Okay, so we'll draw down a number line and you can write 2 and 5. You don't really have to put other numbers, okay? This is already in order. 2 comes before 5, so it's fine. And so we are saying x is greater than 2, not equal to 2. So above 2, you're going to put an open circle because it's not equal to 2. It's just values that are immediately greater than 2. But then by 5, it says less than or equal to 5. So here above 5, we put a closed circle to show that x is also equal to 5. 5 is an included value in our solution. And now to show that we are looking at values that are greater than 2, but less than or equal to 5, you draw a line showing that these are all the numbers they are referring to. Numbers that are greater than 2, but less than or equal to 5, and that is how we would represent that. Okay, and so that is it for that question. Moving on to the next question. Question 3.2 says, a father is twice as old as his son. Okay, so let's just go ahead and start putting this down. So the father is twice as old as his son. So if this is his son, and let's say his son is x years old, then the father is 2x. Okay, so 2x years old. And so 12 years ago, the father was 3 times the son's age. How old is the son now? So 12 years ago, if the father is 2x, then to go back 12 years, we would have to say minus 12, okay? Because we're going back by 12 years. And they're saying that 12 years ago, the father was 3 times the son's age. Now, it seems from the way that it has been phrased, it looks like they're saying 3 times the son's present day age, like 3x. But that's not possible, because if you went 12 years back, you can't be triple the age of your son, because you went back in time. How are you even older than him now? Or rather, how are you older than him then, okay, than you are now? So it may be a trap, but I actually think it's a trap, because if you think about it logically and you actually use numbers to see this, you'd see that that doesn't really make sense. Let's say the father was, let's say the son, okay, let's say the son was 20 years old. And so the father would be 40 years old. 12 years back, the father would be 28. And then there's no way he is 3 times the son's age 12 years back, because then he would be 3 times 20, which is 60. And that is a very interesting way of aging. So clearly that didn't happen. So clearly that's not what they meant. And so what we would have to do is actually think about this logically. So logically speaking, 12 years ago, right? If the father is 2x minus 12 years old, then the son would also age back 12 years. So we would have to think about it like that. So the father would be 2x minus 12, and the son 12 years back would be x minus 12. And now let's read into that. They say 12 years ago. So 12 years ago, this is the father's age. This is the son's age. And they tell us that the father was 3 times the son's age. So whatever the son's age was 12 years ago, the father was triple of that. So the equation is actually 2x minus 12 is equal to 3 times x minus 12. I'm not sure if that was like a trap that they put or, okay, so that's how that would work. And all we have to do is solve for this equation. So 2x minus 12 is equal to, and we distribute, so this is 3x, and we multiply, that is negative 36. Okay, so 3x is already positive here, I'll leave it here. And we can transpose the 2x, so it becomes minus 2x is equal to, this is negative, take it over to become positive 36 minus 12. Okay, so 3x minus 2x is x, and then 36 minus 12 is 24. And there we go. So we know now that x, which stands for the son's present age, okay? So how old is the son now? The son is 24 years old. And that is our answer. Okay, so that is it for that question. Moving on to the next question. Question 3.3 says, if x cubed plus 1 over x cubed is equal to 12, and x squared plus 1 over x squared equals 7, determine the value of x plus 1 over x plus 3. Okay, so this is clearly a case where we can't really just start solving for x, because you can see how they put that. So what we could do is try to get x plus 1 over x with what we have here. Okay, so on one side, you see with this one, I don't really know what to do with that. I can't really do anything right now because there's no such thing called the sum of two squares. Okay, this is an addition sign. If it was minus, we could still factorize. Okay, and then, work with that and try to make maybe this part the subject. So we could maybe have gone through that. So what we can do is focus on this. You see, this one is actually better to start with because we have cubes. We have x to the power of 3 and 1 over x to the power of 3. These numbers are cube numbers. And so this is what we can do with this. Remember that you guys would have learned difference and the sum of two cubes. Okay, the sum and difference of two cubes. So if you have, let's say, a to the power of 3 plus b to the power of 3, this can be factorized like this. You would cube root both of these values. So cube root a, that gives you a. Cube root positive b gives you positive b. Then to get the other factor, we're going to square the first term, square the last term, and then first term times second term, and then just multiply that by -1, or just change the sign. So a times b is ab, and then that becomes negative ab, and that would be factorized. Now the reason why this would work here is because if you cube root this, it's going to give you x. Cube root that, it's going to give you 1 over x. That's x plus 1 over x. Okay, and then we just have to try to make that the subject in that equation. Okay, so we will start using this equation. So x raised to the power of 3 plus 1 over x to the power of 3 is equal to 12. And let's go. We're going to factorize this part using the sum of two cubes. So cube root this and we get x. Cube root 1 over x to the power of 3, okay? Cube root of 1 is still 1, and then cube root of that is x. And it's positive, of course. Then, to get the second factor that we have here, we square this, and it gives us x squared. Square the last term as well, it's going to give us 1 over x squared. And then say first term, which is x, times that last term, which is positive 1 over x, and then you'd multiply this by -1, of course. So this would just, you see the x's would cancel and they're gone. So finally we have 1 times negative 1, which is just negative 1. Okay, is equal to 12. And there we can see our x plus 1 over x, this part. Okay, so we just have to make that the subject. To do that, okay, so you see this part is also showing up. This is equal to 7. So x squared plus 1 over x squared. And this is positive, of course, because we squared that. Okay, so let's just put them together so it makes more sense. We're just saying that x plus 1 over x and then multiply by x squared plus 1 over x squared minus 1 equals 12. And finally, we're still going to leave that, of course. There's nothing we can change it to. We're just trying to solve for it. And we know that these together, okay, they are equal to 7. So say this is equal to 7. And then minus 1 is still there and is equal to 12. Okay, so finally, x plus 1 over x multiplied by 6 is equal to 12. And we can make this the subject finally. So divide both hand sides by 6 to get rid of that 6 there. And so x plus 1 over x equals 12 over 6 is 2. So now we know that this is equal to 2. Okay, so the x plus 1 over x is 2. So finally, the value of x plus 1 over x plus 3, like they asked for, is equal to, since this is 2, plus 3, which is finally equal to 5. And there we go. So that is our answer. And that is the last question for question 3. And that is it for question 3. Question 4, 4.1 says, given f of x is equal to negative x squared plus 4, 4.1.1 asks us to sketch the graph of f, clearly indicate all intercepts with the axes on the graph. Okay, so as you can see, we have x squared. This is a parabola. And it's specifically a parabola that is going to be a sad face parabola, concave down, because we have the value or the coefficient of x squared be negative. Okay, so we know the shape of this graph and we can just find some other things about it. We know that the shape is concave down, a concave down parabola. And let's just go ahead and find its x-intercepts. Okay, so the x-intercepts can be found simply by making y equal to 0. So we'll take f of x is equal to negative x squared plus 4, and we make y f of x equal to 0. And so when we do this, we can transpose the x squared to make it positive. So positive x squared equals 4, and to solve for x, you would square root both hand sides. But we are square rooting, so we need to consider the positive and the negative solution because this is an equation. We have two solutions, okay? We know that finally x is equal to positive or negative 2 because the question is x squared is equal to 4. So we know 2 squared is 4, but negative 2 squared is also 4. Okay, 4, not 2. So that is our answer there. And so our x-intercepts are simply negative 2 and 0 and 2 and 0. And then for our y-intercept is found where x is equal to 0. So simply make x equal to 0. F of 0, okay, in place of x, is equal to negative and 0 all squared plus 4. And so f of 0 is 4. So the y-intercept is 0 and 4. And now we can sketch this graph. So it doesn't have to be, fancy. You don't need a whole lot of numbers. You can just put down your Cartesian plane, that's your x and your y axis, and we're going to plot our points down. So we have 0 and 4. So 0 and 4 units up on the y axis, so that's 4. And then we have negative 2 and 0, so 2 units to the left, negative 2, and 2 and 0 to the right. And then just draw your graph. Okay, it is a sad face parabola, so it's just going to go like that and then down. Okay, so this is our graph, and you can just label it. Since it was called f of x, this is the graph of f, and that is our answer. Moving on to the next question. Question 4.1.2 says we need to write down the range of f. So the range refers to all the y values of the graph of f. Okay, so looking at this graph, it's a graph that is concave down, okay? It's a sad face, and so it means that this graph is going to shoot down to infinity, right? So the y values that it will have, you can focus on the y-axis. Okay, you see on the y-axis, the first place it has a y value, if we look from the top, it's at 4. And then it has y values all through. Because look at each point. Okay, this point over here, that's its y value. This point, that's its y value. This point, its y value is 0. And it will keep having y values all through. But you see that it will not have any y values that are above 4. Okay, so it's values that are equal to 4 and then less than 4. And this is how we would write that. We would simply say y is simply less than or equal to 4, and that is our range. You can also write this in interval notation, which would look like this. But with interval notation, you need to consider the value it's heading towards. Okay, it's going down to negative infinity, and the highest value is 4. So you always start with the lower value. We say y is an element of, it's going from negative infinity all the way to 4. Infinity is not a fixed value, so you use a round bracket here, and 4 is an actual included y value. The graph has a y value of 4. Okay, so you use a square bracket here, and that's what your answer would look like. So you can write it like this or like this, and it's fine. Moving on to the next question. The next question, 4.1.3, says, determine the value or values of x for which f of x is greater than 0. F of x stands for y, okay, the y values of the graph of f. So they're asking, tell us the values of x where you see that the y values of f are greater than 0. Numbers that are greater than 0 are positive numbers. So we're going to look for where we have positive y values on our graph. So here's our graph. Positive y values, or really just y values in general, they lie on the y-axis. Our positive y values would be here, above the x-axis. That's where we find positive y values. Negative y values are below the x-axis. So when we have to select the parts of the graph, okay, where we have positive y values, do you see that that will be all the parts of the graph that lie above the x-axis? All of these, if you map them to the y-axis, this point over here, look at that. It has a positive y value. That point, a positive y value. Even 4 is a positive number. Okay, so let's go ahead and find out the values of x for which these selected parts exist. If you line them down to the x-axis, do you see that we have these values being greater than negative 2 but less than 2? Okay, and the reason why negative 2 and 2 are those points that mark where your answers would be is because at negative 2, this is an x-intercept. This is the point where y is actually equal to 0. So if you go below this, this is where y is less than 0. Above it, y is greater than 0. Okay, so we can finally show them that we are telling them x is simply greater than negative 2, but less than 2. And that is our answer. Okay, it's values that are greater than negative 2, but less than 2. Those are the x values that these highlighted sections line down to. Okay, so that is our answer. And moving on to the next question. The next question, question 4.1.4 says, describe the transformation from f to h in words. Okay, so if h of x is equal to, and they say negative and then x minus 1 and x plus 1. Okay, so from what f of x looked like? F of x was simply just negative x squared plus 4, right? Negative x squared plus 4. Notice how this was just two terms, but now they have given you a factorized form of this. So just distribute so that, you can end up making it look like that, and then you can clearly see what happened. So h of x is equal to, and we're going to distribute. So if we distribute, we're going to multiply, FOIL the binomials first. So multiply x and x, it's x squared. And you can already see this is the factors of difference of two squares. So even if you distribute them one by one, you're still going to end up with this. You just multiply the two first terms, and that's x squared, and the two last terms, that's negative 1, okay? And that's what you're going to end up with. And then multiply this negative in, because you see that f of x has negative x squared. It will be better to relate it with another negative x squared as well. So h of x is equal to, we multiply in negative x squared and then positive 1. Now, what did we actually do to this graph so that it could look like this? Okay, the negative x squared and the negative x squared are exactly the same. The only difference is this changed from 4 to 1. So what did we do? If you go from 4 and then to 1, you clearly went down. Okay, so we took this graph and we're really just taking f of x. So we looked at h of x and we said we're going to take the graph of f of x because it's still exactly the same. The only difference is this is 4 and this is 1. You took f of x and you said minus something to get 1. 4 minus what gives you 1? Minus 3. Okay, so that's exactly what they did. They took f of x as negative x squared plus 4 and they said minus 3. So you have to just think about what this would mean. So if you take f of x stands for the y values of a graph. The y values, okay, lie on the y-axis. If you take all the y values and you say minus 3, what's going to happen to them? If you take this graph and we say minus 3 is all the y values, you are literally taking this graph and shifting it down by 3 units. Okay, so that's what happened. We shifted, or they shifted, the graph of f down by 3 units to obtain the graph of h. And that is our answer. Okay, that's how this became that. F was shifted down by 3 units to obtain h. Moving on to the next question. Question 4.2 says, determine the equation of the function k of x, and they say k of x equals a over x and then plus q, with the horizontal asymptote being y equals 3. And then they say that the straight line f of x is equal to x plus 2 intersects with the graph of k at 2 and 4. Okay, so you can see that this is a hyperbola, right? And it's a hyperbolic function, and they also give us the horizontal asymptote, which is so helpful and actually makes this so much easier. So the horizontal asymptote is y equals 3. So it is a horizontal line and its equation is y equals 3. Remember that the general form, and this is already in the general form of a hyperbola. With that general form, the value of q, that is literally your horizontal asymptote. So we know what q is. It's 3. So we can just go ahead and tell them we know that q is first equal to 3. Now with this info, we can update the equation of k. So a over x plus 3. Now all that is missing to find the equation of k is just a. How do we find a? They tell us this straight line. So there's this straight line x plus 2 that it intersects with the graph of k at this point. See, if you had this hyperbola, so wherever it is, I'm not sure what a is, but let's say it was positive. Okay, if it was positive, it would lie in the first and the third quadrant. There's a straight line, which is, okay, yeah, probably is positive. Because this straight line's equation is f of x equals x plus 2. Okay, so a straight line's equation is always in the form of y equals mx plus c. So the gradient is positive 1, meaning this is an increasing function and then it has a y-intercept of 2. Okay, so it is a line that basically does this. All that this just means, all we need to take away from this is the fact that they said it's going to intersect k, and then they told you where it intersects k. They didn't even let you, have to figure that out. They told you it intersects k at 2 and 4. So now you know there is an actual point on k called 2 and 4. So why don't we just take this point and substitute it into the equation of k, and then we can find what a is. Okay, so that's what we're going to do. So take 2 and 4 and substitute it in place of x and y, since it actually lies on the graph of k. And so in place of y, we substitute 4 as a y value, k of x, and then a over, and then x is 2, then plus 3. And now we can solve for a. Okay, so transpose the 3, 4 minus 3 is 1. So just 1 equals a over 2. And then solve for a. We need to get rid of the 2. It's dividing, so multiply both hand sides by 2 to get rid of that 2. So finally that cancels, and a is equal to 2. Okay, so now we finally know the equation of k of x is 2 over x plus 3, and that is our answer. And that is it for question 4.2, and that is it for question 4. Question 5 says, given f of x is equal to negative x plus 1, so that is the equation of a straight line, so that is that straight line we have there. And then g of x is equal to negative 2 over x plus 2. So that is a hyperbolic function. Okay, we saw like in the previous question, question 4, which are not drawn to scale. So keep that in mind. R and S are points of intersection of the graphs. And then we have this line DBQ is a line perpendicular to the x-axis with D and B on G and F respectively. The coordinates of Q are negative 1 and 0. As we can see, that is an x-intercept. Okay, so the first question, 5.1, says we need to, determine the equation of the line of symmetry of G with a negative gradient. So the graph G is a hyperbola and it has two lines of symmetry. So two lines that divides this graph symmetrically. So we could cut it like that, okay, or we could cut it like that. But they're specifically asking for one. They're asking for the one with a negative gradient. So the one with a positive gradient, and you'd usually use this to find that one with a negative gradient, okay, its equation works like this. Remember that the general form of a hyperbola in grade 10, the equation is y equals a over x and then plus q. Right, so the equation of the line of symmetry with a positive gradient is simply y equals positive x plus q, and then that's it. And then the one with a negative gradient is simply y equals negative x plus q. So all we have to do is find the value of q. The value of q is literally this. So we can see it's 2. Okay, so since we know that q is equal to 2, so that just means that the equation is y equals negative x plus q, which is 2. So plus 2, and that is our equation. Moving on to the next question. Question 5.2 says, determine the coordinates of R and S. Okay, so in this case, because R and S are the points of intersection between the graphs of F and G, we can actually just find it like that. So if these are the points where they intersect, it means at this point they have the same y value and the same x value. Because of that, we can just equate them. So take your graph of f and equate it with g. So f of x is equal to g of x. And so this is going to be negative x plus 1 equals negative 2 over x plus 2. So negative x plus 1 equals negative 2 over x plus 2. And then we need to solve x here. Okay, so this is already a fraction. Leave the fraction here and we can just go ahead and take the 2 over. So we have a negative x, and we could just make these positive. I can take this over to make it positive 2 over x, and then take these over, so that becomes positive x, that becomes negative 1, and then this is still on the right hand side, so it's positive 2. And so we know now that 2 over x is equal to x, and then negative 1 plus 2 is positive 1. And now we can go ahead and solve x. So this is a fraction. You can make this a fraction by putting it over 1, and then you can cross multiply. So x times x plus 1. And you're multiplying the x to the x, which gives you x squared, the x to the 1, which gives us positive x, is equal to 2 times 1, which is 2. And you see that we have a trinomial. We just have to bring the 2 over. So x squared plus x minus 2 equals 0, and factorize. So open up two brackets, equate to 0. X times x gives us x squared, and we need factors of negative 2 that can give us this coefficient of positive 1 in the middle. So that is 2 and 1, and then one of them needs to be negative so that when we multiply, we get negative 2. So if the 1 is negative and the 2 is positive, 2 minus 1 indeed does give you a positive 1 in the middle. So this is positive 2 and negative 1. And now we can solve for x. So x plus 2 times x minus 1 equals 0. Therefore, x plus 2 equals 0, or x minus 1 equals 0. And so x is equal to negative 2, or x is equal to positive 1. So these are the x values. And now we can find their y values because they want the full coordinates of R and S. Okay, so we have a negative 2 and a positive 1. The negative 2 clearly belongs to the R. So that's negative 2. And that is positive 1. you can already see that, okay, they did say it's not drawn to scale. So I'm not sure if this actually intersects here, but we'll find out. So to finally find the corresponding y value, just take these x values and substitute them into either one of the equations of the graph because they lie on both graphs. Okay, so I'll take the easier equation, which is f, okay, negative x plus 1, and I'll substitute. So f of x equals negative x plus 1. So substitute negative 2 first. F of negative 2 equals, okay, so f of minus 2 equals, that becomes positive 2 plus 1, which is 3. Okay, so I can see clearly now that r is negative 2 and 3. And then substitute to find the y value here. And that is 1 is equal to, and we have minus 1 plus 1, okay, and it is indeed 0. Okay, so finally we can see that S is 1 and 0. And there we go. We have found these coordinates. Moving on to the next question. Question 5.3 says we need to find the length of DB. Okay, so the length of DB, and do you see that with DB, we have D lying on the graph of G and B lies on the graph of F, but do you see how they're both in line with this Q negative 1? They said negative 1 and 0, okay? So we know that the x value here is negative 1. This means they lie on the same vertical line. If points lie on the same vertical line, they share a coordinate. So because to get to this point Q, you would have said negative 1 and 0, okay? To get to this point B, you would say negative 1 and then whatever units up we have to go to get to B. So it has the same x value as Q, so it also has negative 1 and then it has some y value, okay? Whatever that y value is, we'll find it. And then here D as well would have an x value of negative 1 and then whatever the y value of D is. So to find the length of DB, just find their y values, because if you know their y values, then whatever that y value is, you take that y value minus this y value and you'd find the length of DB. So the goal is to find those y values. Okay, so we know the x values are negative 1. And I'll just go ahead and present them like that, so it shows that we actually know those now. So B is negative 1 and then whatever the y value of B is, and D is negative 1 and whatever the y value of D is. So because B lies on the straight line, we can substitute this x value into the equation of the straight line to get the corresponding y value. So f of x is equal to negative x plus 1. So we'll say f of negative 1, trying to find the y value that belongs with this x value of negative 1, is equal to negative times negative 1 plus 1. Okay, so that gives us 1 plus 1, which is 2. So f of minus 1 equals 2. And then we can also find the y value of D. And because D lies on G, take that negative 1 and substitute it into G. So negative 2 over x plus 2. So we say G of minus 1 equals negative 2 over x, which is negative 1 plus 2. And so G of minus 1 equals, that will give us positive 2 and then plus 2, which is 4. Okay, so now we know B is finally negative 1 and 2. And D is simply negative 1 and 4. And now we can find DB. So DB, okay, would be take the higher y value, since you know this one is 4 and this one is 2. The higher y value minus the lower one, 4 minus 2. And we can finally see that this is 2 units. And that is our answer. And that is it for question 5.3. That's the last question. And that is it for question 5. Okay, so that is the last question for this paper, and I hope to see you guys in paper 2.